We'll get the meeting started at 7:35. So it looks like this is our group tonight. So I didn't, other than obviously Peter, who said that he had a bit too much of a day today with his, pre-op appointment. So he sent his regrets to myself and maybe others, but haven't heard of anyone else that will be joining us, yes or no. So anyway, welcome. There's Jerry to our first meeting of 2026, a new year ahead of us. So, as always, our little preamble here, note that our meetings are recorded and made available on our public YouTube channel for viewing. And with your participation, you accept and understand that, these meetings are going to be available to the public. So, with that, I didn't have anybody add anything to the agenda items for tonight, so we have Charlie, who's going to be talking to us about op-amp biases and biasing, I guess. And then little discussions afterwards about what you guys are working on, RF related or not. So anyway, that's it. Why don't we dive right in, Charlie, if you're ready to rock and roll?
Sure.
Yeah.
Let me see if I can share. Share. I'm still have a bit of teething pain with my the computer here, since I'm for the first time I'm 100% Linux. So some things work properly, and some things are a bit of a challenge. Does everybody see that for starters?
Yep, looks good.
All right, so this chart is just an introduction, and one of those be careful what you search for on Google. If you search for operational amplifier bias, lo and behold, I found someone who's biased towards op amps, thinking that op amps are superior to girlfriends, and that's because they're financially sound investment where girlfriends can be financially draining. Op amps are great at parties. Girlfriends sometimes not so much. And on and on. So, no, mind you, this isn't actually the topic of discussion this evening, but this is not the type of bias that we're going to talk about here. So diving into the electronic parts of it, if you look at it, kind of a traditional op-amp circuit, and I'm just going to pick on the LM358 to begin with. Very standard circuit here, gain of 10, which is because it's an inverting gain. It's this 5K resistor over the 500 ohms is what sets the gain. So if you put a 1 volt peak to peak into it, you'll get a 10 volt peak to peak out. And in that particular case, with the 10 volt peak to peak out, well, we should be able to power this with 12 volts, right? We just use if we don't have, the positive and negative rails that op amps like, you just use 12 volts and 0, a couple of equal resistors.
Charlie, sorry, if you don't mind, Kevin's got a question for you.
Sorry, I'm not seeing the circuit. All I'm seeing is the first slide. I don't know if I'm the only one or.
Yeah. Have you? I don't think you've advanced yet, have you, Charlie?
I have, yes.
Oh, okay.
Yeah.
No, we're still on the girlfriend screen. So.
Yeah, we're still looking at the pretty girl there. Oh, there we go. Okay.
Did it work that time?
Yeah, not as fun, but yes. This is fun. Thank you.
Okay, good. Well, thanks. I'm not sure why that happened, but yeah.
All right. Right away after you did it the second time. So.
Yeah. Well, we'll be sure to point it out if it doesn't work again.
It was funny because you could see your mouse pointer moving around, but the screen hadn't changed. So
Right. So I guess to just go over that again, then we've got a 5K resistor and a 500 ohm resistor. And since it's an inverting circuit, the gain is R2 over R1. So this shows a gain of 10, 1 volt peak to peak in, 10 volts peak to peak out. The key message here is that since we're only swinging 10 volts peak to peak, if I've got a 0 to 12 volt supply with a voltage divider from the mid rail, then this should work perfectly fine, right? And this is what most of us would do if we were just slapping this together without a whole lot of thought. Just to clarify, if anybody's not sure what that resistor divider circuit might look like, I'm sure you've seen it 100 times, but if you haven't, this slide should show our 12 volts and our 0 volts. We've got a couple of 1K resistors and some bypass capacitors, which goes to the positive input, and then with 12 volts and 0 volt supply, everything should be cool, right? Well, for giggles, let's have a look at the spec sheet, just to go through first principles. So in terms of a supply voltage, no issue. We can go up to 32 volts. And in the absolute worst case, although the recommended voltage for the supply is somewhere between 3 and 30 volts. So as long as we're under 30 volts, 12 is under 30 volts, and it's greater than 3, so Bob's your uncle, this should be just fine. But there's another line on the spec, which is how close can we actually swing that output voltage to the rail? Now, if our amplifier is putting out a current of 1 milliamp, and it is, because if we go back up a couple of slides here, we've got a 5K ohm resistor for R2, and since the output is going to swing at plus 5 volts, the negative input is a virtual ground, so it will be at 0 volts. So I've got 5 volts, 5K, yep, that's a milliamp. So we're going to be drawing a milliamp when we swing in either direction. So at a milliamp, you actually can only get within 1.48 volts worst case of the rail. This is typical on worst case here. And for the negative rail, typically 3/4 of a volt, and worst case 1 volt. Which means if I put this, down, draw it as my circuit down here, I've got my 0 volts in the middle. Plus and minus 5 is my 5 volt peak to peak swing. Because I have to have some gap between the negative point and the rail, I need a minus 6 volt. And then up here at the top, with 1.48 volt, I need a 6.48. So when you add that minus 6 and the plus 648, suddenly my 12 volt supply isn't going to work. Instead, I need a minimum of 12.48 volts. Now, why can't you swing right to the rails? If you look at the typical op-amp schematic, it's easy to see where the output is here. There is you can't get this base below 0, and there's always going to be a diode drop here. So this output can't get any closer to 0 than this 0.6 volts. And usually there's about a 0.2 volt here. So now we're at 0.8 volts. And, it's easy to see how with these volt drops and so on going on in here, there's about a volt in there that you need to worry about. The top end is even worse. You've got a couple of diode drops to consider, as well as because there's some current flowing in this resistor, there will be some additional voltage on that. So, only being able to get this output to within on the order of 1.5 volts of the positive rail is it's pretty easy to see how that can happen with that very, very typical op-amp design. So based on that, we've got the 12.5 volts that we need to worry about. Now let's talk about faking this this lack of dual supplies, this plus and minus supplies, which op amps really like, by using a resistor divider, right? So we need to create this virtual ground, and to create this virtual ground, we're using these two resistors, so they're the same value. So the equation for that is it's really R2 over R1 plus R2. And if we've got perfect components, everything's cool. This works out to 0.5. So our 12 volt supply across here times 0.5 is 6 volts, puts us dead smack in the middle. That's all good. Unfortunately, there are no perfect components. So, let's say for giggles, we've got 5% resistors rolling around. Should make a huge difference, right? Well, it starts to make a difference if you do the calculation with that, that with the resistors being 5% off in opposite directions. Now suddenly you're looking at this R2 over R1 plus 2. R2 is 0.515 or 0.4847. So if the supply was 10 volts, and I just used 10 volts because it made the math easier in my head the day I was doing up the charts here, now we're looking at 5.2 or 4.8 volts here. So now we've got another 0.2 volts that we have to add on that previous chart, where we're talking about the 6.48. Now it's 6.68 and minus 6.2, right? So now we're looking at a 12.88 volt supply in order to do a 5 volt peak to peak swing. Also haven't talked about input offset voltages or currents, but these do contribute to the error. And even though they're tiny, they get multiplied by the gain of the stage. So for the data sheets, we'll spend a bunch of time on this. They're about plus or minus 7 millivolt. Our current amp has a gain of 10, which isn't huge. Now our 12.88 volts became 12.9 volts. But our gain is 10. There are circuits out there with gains of 100 or more, and in which case this can start to become quite significant. You need to think about that.
Charlie?
Yeah.
I'm doing an op-amp design right now for the backplane, and I'm using R1 and R2 at 46K. Why are they so low here, or is it arbitrary?
It's not arbitrary at all. I'll talk about that in a second,
Okay.
actually.
Okay.
And I think the answer is going to end up being for you is that you're going to want to change them. There aren't many currents flow into that op-amp input. It's very, very low current. So that's not the issue you need to worry about. The issue you need to worry about is that you want it to be a really solid virtual ground at the frequency that you're working at. So if we look at, these sides are equal, basically, because the positive supply and the negative supply are, from an AC perspective, they're an AC ground. The midpoint we also want to be an AC ground. So we want to decouple this to these two supplies as best we can. And this particular circuit that's being used here is, some very large 220 mic caps and then 0.1 mics. And the 0.1 mics are really added because these 220s are, they're going to be electrolytics at that large a value. And because they're electrolytics, as the frequencies go up, their equivalent series resistance and equivalent series inductance goes up. and start to become significant as the frequency increases. So the 0.1s really are to kind of roll things off after that ESL and ESR start to come into play. So if we calculate, what the impedance of this is, or rather where the cutoff frequency is, that cutoff frequency, or the 3 dB point, is calculated as 1 over 6.28 times RC, or in this particular case with the 220 and 1K, 0.724 hertz. That's the 3 dB point. So if you want this to feel like a really good solid ground, the kind of rule of thumb is to multiply that by a factor of 10. And so this virtual ground is, with this circuit in place, it's basically good to 7 hertz. It's anything above 7 hertz, it's a virtual ground. Below 7 hertz, it's going to be pretty crappy ground. But in this particular case, we don't really care, right? But if you look at the circuits that we tend to use in our designs, we often don't have these large 220 megafarad caps in place. We only have the 0.1s, and if you've only got the 0.1s, then that frequency is 1592 hertz. Now the ground's only good down to 15 kilohertz, which, if you're doing an audio amplifier, you're pretty hosed. 15 kilohertz is, the top end or beyond what we're trying to amplify, particularly for radio, where usually 3 or 4 kilohertz is what we're trying to do. And if we use 10K resistors instead of 1K resistors, now suddenly we're only good down to 150 kilohertz. And, if we're doing that with our RF stages, maybe it's okay. Depends what's the lowest frequency that we're trying to detect. If we're, down 3.5 meg, yeah, probably not a big deal. But if you're going to some of the lower frequencies, the 1.8 meg even, this is starting to feel like potential for noise. And if you're going to some of the really long wave stuff, well, this is a huge problem. So 2 things to worry about when we do this decoupling, right? One is, again, it depends on your circuit. Or if it's an op-amp circuit, you're not putting any real DC currents in here. You're really looking at AC currents that you want to shunt in, and this DC is purely for a reference. So, the problem with 1K is there's lots of current flowing in there, so that things get warm, you're wasting power, yada yada. You do better to make the resistors larger, but also double the size of the caps and so on. But then they start to get physically large too, right? So the really thing that drives your choice of these components is, in all honesty, is what's the frequency that you want to work at. And so let's talk about a higher frequency circuit. So I'm going to move away from the 358 op amp audio stuff for a minute, and pull a practical example that I came across, which is the preamp that's currently being used by Peter in the backplane radio. It's been used in Phoenix and a couple of other places when I discussed it with Peter that he's pulled the circuit from over the years. So it's using an LT1253, which is a bit of a slightly different beast. But in this particular case, there's that filter, 10K ohms and 0.1 mic. So that 10K ohms and times 2 and 0.1 mic. This is really, pushing us up to that 150 kilohertz. In fact, I would argue that the 0.1 mic is really half that. Might even be closer to 300 kilohertz that we need to take into consideration here. what I mean by it being only half of that is that, normally you'd have a decouple here to the +5 and a decouple to the ground. So since there's only one decouple cap here, it gets split between these two sets of currents. So in either case, it's a very high frequency, and I think this, really needs to be kind of reconsidered. And then the other thing that you notice is that, this voltage is referenced to, it's a 2.5 volt reference with a 12 volt power supply. So, what this says is, if we look at our LM358, where we can swing within a volt of ground, we're biased here at 2.5. Well, we can only swing down minus 1.5 before we're hitting the rail in the worst case. So therefore, you can't do more than 3 volts peak to peak, even with a complete 12 volt supply up here. Now, this is an RF preamp, so it's not going to need anywhere near 3 volts peak to peak. So it's probably okay in this application. But hang on just a sec. This is actually using a 358, right? So off I went and I dug out the specs for the 1253. The 1253 is a current amp as opposed to a voltage amp. And because of that, the way they specify things is a little bit different. But we can compare it to the 358 fairly easily. So for instance, if we were powering this thing with ±5 volts, and we've got a load resistance of 150 ohms, then typically we can swing ±3.7. So ±3.7, if we were biased on 2.5, that says we can get we can swing within, kind of 1.3 volts of the rail. But this is the kicker here, is in the worst case, ±2.5 is all you can do, which means you can only swing within 2.5 volts of the positive rail or 2.5 volts of the negative rail. So what does that look like? Well, if we come back to our biased at 2.5 volts, this line that thou shalt not attempt to go beyond is 1.3 volts on a typical part, but in the worst case, it's at 2.5 volts. But this line's at 2.5 volts. So if both of those things are at 2.5 volts, not taking into account tolerances in the resistors or anything like that, the circuit isn't going to work, period. If we get a worst case part that is still in spec, we're sitting at, we cannot swing below 2.5 volts, but 2.5 volts is where we're biased at. So we can only swing positive. So you cannot have a linear amplification at all with this particular situation. Now, that worst case part is, I don't know what the part distribution is. It's certainly going to be well beyond 3 sigma, probably beyond 6 sigma. It's out there on the hairy edge, but it's still considered a good part if you get one at 2.5. So in the stuff we're doing, we might never see one, or, we might buy a batch of 10 of them and they're all on that case, because it's going to be die specific. So, it's possible that we could get all worst case parts. What are your odds if you buy a lottery ticket? So, how do we change this? Well, the first obvious change is change that voltage divider reference to 12 volts from 5 volts. This will allow us to get, kind of a 7 volt peak to peak swing Again, we probably don't need that much of a swing. The amplifier, if you calculate it, we'll go back to it for a sec here. This is a non-inverting stage, so its gain is this resistor over this resistor plus 1 because it's we're using non-inverting. So 680, if this 1K is at 0 over 68, that gives us a gain of 10 for this stage, plus 1 is 11. Exactly the same here. So 11 times 11 is 121. So this has a gain of 121. Now, it's connected to an antenna, so what's coming in that antenna is going to be somewhere between a millivolt and a microvolt, I would say. If it's a millivolt, a gain of 121 millivolts is still, a tenth of a volt, basically. So it's not a huge signal that we're dealing with, and so consequently, as long as we get that 2.5 bias out of the way, it doesn't really matter if we need to get a 7-volt peak-to-peak swing or whatever. We don't even need a volt peak-to-peak swing on the output of this thing. Going through the specs, the circuit's not guaranteed to work with a single 5-volt supply. So, and that's because of the 2.5 volt worst case on either side of it. So a single 5-volt supply isn't a possibility. We could use a single 12-volt supply, and get the reference from 12 volts, or even just use the 5-volt supply itself as a reference, which would be fine. But in terms of the backplane radio, at least, we've got plus and 5-volt supplies and plus and minus 12-volt supplies. Why don't we just use them? And in fact, if we do that, we end up with a really minimalist component count. This is the thing that kind of surprised me once I started going through it. So if we use the plus and minus 5-volt supplies, well, we don't need these resistors and capacitors. All of that goes away. This 200 ohm goes away. The coupling cap to the antenna goes away because this is essentially at ground potential. So even if the antenna is a dead short to ground, which it often will be at DC, no issue. It'll all work quite happily. You just run a 51 ohm resistor to ground if you want a 51 ohm input resistance. And that's a topic for another discussion, because for a receiver, I'm not convinced that that's necessarily the right thing to do there, but let's pretend that it is. We at least nuke this cap. Whoops, my bad. Let's go back here. We nuke this cap, we nuke this resistor, we nuke this cap, we nuke these two resistors. We nuke this connection to 5-volt supply. Over here, these were coupled through caps to circuit ground. Don't need that anymore. These go to this to the 0-volt regular ground because we've got the minus 5 volts. So those caps get nuked, that one and that one. The output of this drives into a transformer, and because there's no DC bias to worry about, that cap gets nuked. Some of our filter caps can start to disappear. You can see we're taking 3, 6, 8, 9 components off the board, simplifying things, and ending up with a really solid ground that isn't frequency dependent, because we've got decoupling caps all over the place. We no longer have to worry about that 150 kilohertz or what's the frequency that that this stops being a good ground reference? The answer is 0 hertz, because it's ground. It's fine at DC. That would be my recommendation. The other note I stuck on here is because weird stuff can happen in antennas, some clamp diodes here, particularly if there's no current limiting resistor here, which honestly, it's also reducing the gain somewhat. If we put some clamp diodes here, just in case we get a lightning strike a couple of blocks away, that will protect us from that transient. Nothing protects you from a direct hit, of course, but noise transients that are happening out there. A pair of clamp diodes here, pretty cheap insurance to kind of protect these 1253 amplifiers. And that is the end of my presentation. Are there any questions?
There's no hands raised at the moment, but until now,
There's
there we
one.
go. Kevin.
Okay, so yeah, I mean that was my first thought, Charlie, when you were going through this, and it's like, well, why would you ever use a single supply? Just go to dual supplies and be done with it, because I mean the op amp circuits I'm used to dealing with, mind you, that was many decades ago, but they use just dual supplies everywhere because it's just easier. and
I guess the answer to that is in our case where we've got all the supplies, non-issue. But if I'm building a radio that only has that I want to use in the field somewhere and I want to run it off a battery, I've only got one supply, right?
That's true. Yeah, I mean you only have one 12-volt battery, but I mean, excuse me. And but anyway, yeah, it's like but even with the offset currents, now I'm not sure how that 1253 works, but I mean, if there's a gain of 100, and that spec sheet, if I remember right, had the input offset current was microamps, so it's going to be getting maybe close to milliamp on the output. So maybe would you put a trimmer in there to zero out that offset from the amplifiers?
I don't think so, because it's being an RF preamp, we probably don't care if we're off by quarter volt, half volt kind of thing, because we don't have a big swing that we need. We're swinging less than a volt, so then we're going to have with plus minus 5 volt supplies, we're going to have a 5 volt peak to peak signal that we can handle without any distortion. So it doesn't really matter.
I was thinking more just in the case of if it's going into a transformer for coupling into the mixer or something like that.
Yeah,
you don't want any DC going through the transformer, right?
Exactly. Yeah. So I mean, I don't want to dive into doing a design of the circuit here and going through all the details of it. I think that's for another day. But this was really just around the biasing and so on. The other thing that I think is worthwhile doing at a future meeting is these 1253s are current amplifiers, which are a different beast from the voltage amplifiers. And I started poking around these things actually only just a couple of weeks ago, because I've always used voltage amps, never used a current amp. Don't know why anyone would want one. But it turns out that there are some very cool advantages. For instance, that feedback resistor actually sets the bandwidth. So with a voltage amp, you've got a fixed gain bandwidth product. And if you bump the gain up by a factor of 10, you're going to reduce the bandwidth by a factor of 10, more or less. Whereas with a current amplifier, that's not the case. You can kind of fix the bandwidth and the gain independent of each other, which makes them really interesting. There's things you can't do with them. The non-inverting input is high impedance input, like with the voltage op amp, but the inverting input is actually a very low impedance. So you need to think about that somewhat when you're designing your circuit. But maybe that's a presentation for another day. I've got a lot more homework to do before I can talk about it with any kind of.
Yeah, I haven't done a lot of work with the current amps. Certainly not the latest ones in any time or anything. Okay. Okay, Michael, your turn.
Charlie, I mentioned my circuit. This is the. Do you mind if I share the circuit?
Not at all.
Let me see if I can do it. Share here. Here. Is this going to work? No, it's not. Why didn't it work?
Well, you shared a screen.
Let me try again. Oh, I've got to go to the amp. Well, I guess I can. Yeah, there is the amp. So okay, now I go. I can't share it. Wait a minute. Share screen. Okay. Entire screen. Here. So now I should be able to.
Yeah, we can see everything now. So.
I'm going to pick up here's the.
Got it. Yep.
Okay. Not to belabor things. This is based on the Phoenix amplifier. This is an audio amplifier that I've been working on with Peter, and it's basically just a copy of the Phoenix amp. And here, these are the 47K resistors I was talking about, rather than the 1K. And there's no bypass capacitors across these. This is for 12 volts, right? So there's two preamps here, one here, both biased the same way. This is neither here, and this is a tone control, and there's an LM380 over here.
So they've what they've done here is so this input, the positive input that you have here, needs to be at half rail, basically.
Which it is,
so they're using the 47Ks to put the voltage at half rail, because there's really no current going to flow into that input. In a perfect world, there's no current flowing into it. In reality, there's a tiny little bit, and that is limited by that 5K resistor R27. So I mean, this is a way of doing it that it works in this particular case. You're not creating a virtual ground in this case. What you're creating is basically a high resistance voltage reference, if you like. So you wouldn't want that particular node to be an AC ground. If it was, you'd get nothing. Your V2 signal would go nowhere, right?
Just another question. These capacitors, this one and this one, what are these things? What are they doing? This is just the feedback network here, right? R5 and R4. So the gain of this one is 33 plus 1 is 34, you would think. Right?
Yeah.
So what are these things doing? What is the 470 picofarad capacitor doing? What's it there for?
So without going into the design in depth, typically that is done to change the gain at a higher frequency. So it's used for peaking the output. So the gain is let's see, R5 over R4, 1 plus that, because it's in
35, 34.
Yeah, but when the frequency gets high enough that this 470 puff starts to impact the value of the 33K,
Mm-hmm.
then the value of the 33K goes down with
Going to
frequency.
change the gain. Yeah. Okay.
It's going to change the gain. Yeah.
Yeah. Okay. That explains that. Yeah.
But again, at this circuit, I would change this circuit to work with positive and negative supplies. Plus minus 5 is, or plus minus 12 even, depending on.
Well, we have that. We have that on the back plane. We also have plus or minus 15, don't we? Actually, I think. But we got plus or minus 12. Yeah. Okay.
Yeah. I mean, you have to go through the specs and see if you can get away with that, but certainly that would make life so much easier.
This is an audio amp. So you were talking about RF amps in your presentation. This is an audio amp. So presumably, my thinking is it would be used with Peter's superhead receiver, I would think. If that's the case, then you need to go up to maybe 3K, 3,000 hertz roughly, and that's about it, because you're not talking about higher frequencies in the multiple kilohertz other than 3 to 4.
Right.
Yeah. Okay. Well, thanks.
Sometimes these the 470 puff, for instance, is put in here to help with stability of the amplifier. So,
sorry, what did you say, Charlie? The ability? What?
The C3, the 470 puff. It's a 33K R5.
Yeah.
Sometimes frequency tweaks like that are done more for phase tweaking than anything else, and it's to help the amplifier remain stable and not oscillate at some higher frequencies.
Yeah. Okay. Okay. Thanks, Charlie. That's good. Appreciate it. I'm going to unshare here. So, yeah.
Anything else?
Nope. Okay.
All right.
That seems
Read
good.
your data sheets.
All right. Thank you for that in-depth overview. Lots of information there, but I think some of it have to go back on the recording and maybe actually try out some of the circuits to see, the actual the effects. That's what I would be interested in myself. So, very good. Thanks for the theory there. So,
Charlie, could I ask you to send me the presentation?
Slides?
The slides, yeah.
Yeah.
Yeah, for sure. I'll happily send those along, Michael.
Okay, thanks.
And it sounds like you had, Charlie, a little bit of thought starters for future discussions potentially there. So, hey, it's funny how it grows. Okay. So I think we will just go around our small table here and see what everybody is currently working on. And we'll start with Al. You're first on my screen if you're or like to tell us what's going on your bench.
Not a heck of a lot, actually. I'm still rebuilding my shack in my basement. Progress is happening. I am playing around a little bit with some antennas right now. I think I mentioned previously I picked up it's a JP7, basically a Pac-12 antenna. And so I'm machining up some bases and tripods and all that type of thing to get that functioning. So maybe in the next month I'll be able to set it up and see what it does. But apart from that, not much else going on. Like I say, I don't have a working workshop right now, so I'm a little dry, nothing to offer.
Is that JP7? Is that portable?
Yeah, it's kind of modeled after the Pac-12. It comes with a 5.5 meter telescoping whip. and a loading coil, and a stake to stick it into the ground, and a radial plate. Um, since it's the winter time right now, I really can't put the stake into the ground. So I'm working up a tripod to try it. We'll see how that works. But
Bit of a raised vertical then, I guess.
we'll see what happens. The other thing, I picked up a Y fitting, so I can actually do basically a buddy pull with this thing. Put it on top of a tripod. Take two of these 5.5 meter whips on either side, and then I've got a 20 and up dipole. So playing with that as well. But of course, getting the right adapters and fittings is always a problem. I've got a tripod that's based on a microphone, so that's a 5/8 27 thread, and of course the fitting I've got came with a 1/2 inch MPT pipe fitting. So I'm machining a few bits and pieces up to make this all come together. So maybe in the spring I'll have something to show.
Oh.
Apart from that, that's about all I got right now.
Okay, very good. That's the Chelegans brand, isn't it? That JP7, if I'm not mistaken.
Oh, geez, I couldn't tell you.
Just sounds
Is it
familiar.
even
That's all.
true? Actually, I've got one piece. I got this is the actual Y fitting. Is it going to focus?
Yep.
Okay, so
You'll
each
have to turn
side
your camera
is-
on now.
It's actually on. Maybe just the video's not coming through to everybody, but I can see it. JPC-7. Yep.
Yeah. So it's basically an upside down V, like a set of rabbit ears, and then on the bottom is 1/2 inch MPT. But you can see I've actually made the adapter bushing here for the standard microphone stand. So that's going to go on top of a microphone stand, then a couple of telescoping whips on either side, and we'll see what it does. I saw it and I decided that it was too much work to actually machine something like that, and it was only about $40. Not too bad if you say it quickly. And had to come. I got onto AliExpress, and next thing you know, I owned it.
Yeah, nice. Okay. All right. Thanks very much, Al. Looks like we have somebody sharing a screen. All of a sudden, mine has gone white here. So
Same here.
Likewise, it's white.
Yeah, not
Hang on, I might have hit something here. Hang on. I was hitting.
I guess we're seeing everybody's mice here where they are on the in the Jitsi universe.
Whiteboard, maybe.
Play like asteroids or something. Aren't we here? No.
There's a whiteboard setting, isn't there? Somebody just mentioned that.
Yeah, you know what? You're probably right. Somebody's got whiteboard turned on.
Hang on.
I just
Sherry's writing whiteboard.
Who's writing?
I'm back to normal now.
Hang on.
I toggled between everybody and the white screen. So,
Or
okay.
we start
This
drawing.
is weird.
Whiteboard, it says whiteboard on the.
Okay.
Play X's and O's.
I think I was the one that did it. So now how do I stop it?
Okay, go.
Is it gone now?
No, it's still there.
See, the problem is I'm on my tablet too.
Mine came back.
Thank
You know
Mike.
what?
I appreciate you fixing my crosshatch there. Yeah.
I'm going to log out and I'll come back in.
Yeah.
Okay. That might be the easiest.
It came back for me by on the toolbar hitting the what is it, the
Hide
matrix
whiteboard.
button.
Yeah, just hide whiteboard on your bottom. You're right, on the toolbar.
Hide
What,
whiteboard.
is there a hide whiteboard?
Yeah. So right beside the hang up button, the three dots, if you maximize that, you'll see show or hide whiteboard towards the bottom. So
Okay, I've got show whiteboard.
it looks like that's the only way. We've never used that before. I don't know how useful that would be.
It's gone. Mine's gone. Okay, that
Yeah.
worked. Very good.
Okay, interesting.
Where is that setting?
Right beside the bottom toolbar, you see on the far right side the 3 dots. Hit that, and then
Yeah.
click Hide Whiteboard. It's 4 or 5 options up.
Okay, okay. Now I see it. Yeah.
Yep.
Got it.
Yeah. All right. Momentary lapse of reason there, but we're good now. So, Charlie, anything else you'd like to share with us that's going on with you?
Spending lots of time on lots of different projects. Got too many things on the go, I think. But between backplane radio and doing some 3D printing things, and a couple of little bench projects here, and also a few folks I've been talking to are interested in doing a winter field day this year. So there's a whole collection of things that are chewing up time, unfortunately, right now.
That would not be the RAC Winter Field Day. That's already come and gone, has it not?
No, January 24, 25 is the official Winter Field Day, which is basically the same thing as the one we do in the summertime in June, but it's wintertime. So we
Okay.
go find an off-grid spot that's hopefully a cabin that's not too cold, or a tent if you're hale and hardy, and fire up a radio and make some contacts.
Right. Nice. Okay. All right. Yeah. For some odd reason, I thought I saw that on the calendar that there was some sort of winter contest that was on, but maybe it wasn't field day. Don't know. So, yeah, very good. All right. Thanks very much, Charlie, and Al, for that matter. Didn't thank you, but Frank, how are things down there in Amherstburg?
Hey, things are pretty good in Amherstburg, but I have absolutely nothing to report from the bench. Not that I've abandoned everything, but over the holidays I put it all away, and that was it, and I just enjoyed the holidays. However, I did drag it out on Monday this week and said, okay, new year, we're back to new things. And I'm still working on the digital dial display and getting absolutely nowhere. So I spent a day and a half on it this week and still didn't get anywhere. I did buy a something to make life a little easier. And it's this board here that you plug the ESP32 into, and all the different wires I play with go in the side of the connector, and you just twist them down. Because I'm changing the leads between the display and the microcontroller all the time till I get the right combination. And so far it's not coming. But I'll keep at it. Maybe in a couple of weeks I'll have something to report. So that's it from Amherstburg.
Okay. All right. Thanks very much, Frank, for sharing that, and good luck. Look forward to hearing some positive results. Okay. Howard, what's going on with you?
Well, I've been working on 2 things. One is a filter board to address the harmonics issue on the T41 that I've been working on for the last couple of years. And started aligning, I acquired a Heathkit HW9, that QRP rig from the 80s. And started aligning that, and I think I broke one of the old style variable inductors, the sort of tower type things. So now I have to take more of it apart, but that's part of the fun. That's pretty well it.
Nice. Would there be any correlation to aligning HW101?
Well, I guess in theory the principle is the same, except I'm not sure if it has those same variable inductors in them.
Right. Okay, I might have to pick your brain once I get into the one that I acquired last year. So,
Yeah.
Yeah, it needs a little bit of TLC, but it's one of many projects that I've got, obviously, like all of us. But anyway, all right, good to know. An HW9, is it? Yeah.
Yeah, it's a transistor or solid state QRP rig.
Right.
And from early 80s, I think. I used one a long time ago, and I came across one I couldn't resist. So but it was working fine, or it was working, but the VFO indicator didn't line up with the actual transmit frequency. So I figured I'd do an alignment anyway for the rest of it, and I twisted that a little too far because you can't really see in it. It's one of the ones with the can around it, for shielding.
Oh, okay.
So, but we'll see if I broke it or not once I take it apart more.
All right. Okay. All right. Thanks very much for sharing that with us, and we'll move on to Cherry. What's going on in your shack there?
Nothing much. Like I was couple of weeks I was on vacation. I flew to India and came back. So a lot of activity over there, just taking care of parents and so on. And when I'm back, I got a couple of audio stuff. I was interested in that for a long time, so I thought, okay, let me go ahead and get those things. Bought a couple of speakers and a receiver. So it's playing some music all the time recently. That's the only thing which I've done recently, and I just wanted to get a DAC. Now I was looking at researching and getting a DAC if possible. On the radio side, plan to do a crystal checker. I have some crystals here on my desk, and I just wanted to just test how are those crystals working. So that's all what I got right now. And I plan to assemble a PCB, a Colpitts oscillator, which is like the standard Colpitts oscillator to check those crystals. I have a small PCB here somewhere. I don't find it now, but I plan to get it and try to do it soon. So that's the whole thing on my side.
Okay. All right. Well, glad. Did you bring back any electronics from your trip?
This is the one.
The bag of crystals. Okay.
Yeah.
There you go. All right. Well, you'll have to let us know where we could go in India if any of us travel there. Good spots to the equivalent of Shenzhen in India. Wherever that is. So.
Yeah, I can give you more information. Yeah, I think there are a couple of streets in Bangalore, if it's cheaper over there, and also in New Delhi somewhere, but I've never been to those places. In Bangalore, yes, there are lots of places where you get a lot of electronics which is cheaper. But the quality has gone down a little bit. I think we used to get a lot more quality stuff in the past, but still there are good shops around in Bangalore.
Mm-hmm.
But not a lot these days. That's what I would say. But there are still good shops where you get good stuff. Yeah.
Right. Okay. All right. Thanks, Jerry. Kevin, what's going on down there in Stratford?
Well, since I got the backplane radio, my circuit board done and got it back from JLPCB, that was my first experience with them, which was pretty good, I gotta say. It's so cool that you can send some circuit board design halfway around the world, and a couple of weeks later it shows up in your porch for $5.50. It's like crazy. Anyway,
Nice.
And I had it's like, and they built it exactly how I told them to build it, so it's like, no complaints.
Yeah, it's different when you see it appear for your own eyes rather than just hearing about it. Yeah, nice.
Yeah, it's amazing how you very quickly pick up on the mistakes you made. Anyway, so there's that. And then I had a half-finished Q, and that gave me a burst of enthusiasm with getting that done. And then so I had a half-finished QMX, the QRP Labs radio.
Yep.
So I finished that and got it together, and I haven't finished testing it, but I got power on and no smoke and all that kind of stuff, and it seems to be working. So, but anyway, it's got to be all aligned and whatever. So, and I just want to make sure everything's working. So there's that. And then I had another kit that was languishing in the bottom of a drawer somewhere. I'm sure, Eric, you must know that feeling. So, and it was one of these Arduino PLC kits. I don't know if you've ever seen it. That Universal Solder sells them. I don't know who else sells them. It's just a bunch of 24 volt or inputs at 24 volts, bunch of relays, all driven by an Arduino. And so anyway, I put that together, and because I'm not going to use it if I don't put it together. So I thought, well, okay, I've got to get it together. Anyway, so yeah, it's like, and then I got the boards back from JLPCB, started putting components on, and that brings me up to today. So it's like, it's been a productive couple of weeks, or a few weeks over the holidays.
Did you use your homebrew pick and place machine to populate your board?
Yeah.
No?
Yeah. Squinting through, the glasses and the loop, to put the parts in, and yeah, with tweezers, handheld tweezers.
I'm currently listening to a podcast where a guy has I guess for home use, sort of, for the serious home user, a pick and place machine that, if you're so inclined, if you're doing lots of prototyping.
Why not?
Whatever.
Because we can, right?
Yep. So there you go. But anyway, okay. All right. Very good. Thank you for sharing that, Kev. My last on my screen is Michael. What kind of RF things have you got up your sleeve these days?
Yeah, I've been was away for Christmas and came back and been playing around. The first thing is I got the same power supply that Kevin got, this SPD 3303 from Siglant. I'm very pleased with it. It seems to be pretty good, and figured out how to work that. And I've been working mostly on the backplane audio amplifier, the circuit I just showed. And I started out doing the KiCad stuff and got partway through that. And then I thought, well, probably a good idea to breadboard things. So in the meantime, I did the LT Spice thing and fiddled around with that. Still haven't got that completely working. Not quite sure why, but anyway, it doesn't matter because I went on to do the breadboard. So I started with the power amplifier LM380, got that working. And right now I've got both stages of the NE5532 preamp things, both circuits working individually. So with what appears to be the right gains. So I'm going to connect them together tomorrow. And then I'm going to go see what I get with them both connected together. I presume that'll work. And then the next stage is going to be probably putting it to the LM380 to see what happens. And then lastly, I'm going to build there's a tone control board, tone control part of the circuit. So I'm going to do that. But I'm partway there, which is comforting, I guess. Along the way, I discovered that with the signal generator, which is a Signet 1032, I fiddled around. I thought I would use the high Z setting, and then then it turned out I didn't really understand how that worked. And I spent most of yesterday trying to figure that out, yesterday and the day before. And there's a stack exchange, EE stack exchange write-up on the how that works, how this high Z and the 50 ohm thing work. I think I've got it more or less figured out. It seems to be working okay anyway. And so I'm getting there, I guess. And speaking of kits, I still have the DCR. I've got 2 of the DCR kits. Neither of them built yet. One day, and I'm gonna do what I think Al was saying. I'm gonna build a. I'm gonna do some crystal testing. I bought some crystals. I'm gonna use the scale, the SNA's circuit. Plus, I'm gonna make the Kevin's Peter's boards. I think to test the crystals. And I guess that's it. The other thing of note is after 33 years of DXing, I got my 5-band DXCC.
Oh, nice.
I got 100 on 80, 101 on 80, and that actually got 8-band DXCC, but it only took 33 years. Anyway.
Congratulations. Yeah.
Yeah. Well, a lot of work, a lot of frustration. What made it for me was I had an 80-meter antenna, sort of, that part went straight back from my tower to the fence, and another part went across. I have a semi. The other part went across my backyard and my neighbors. So it's sort of a V, an inverted V thing. Well, Daniel V3 and I moved the leg that was over the neighbor's yard to the front of the house. So now it's sort of straight, and it works. So I've got 101 on 80, which is all I needed. So anyway, enough about me. That's all, really.
All right. One thing I wanted to ask you, Michael, I noticed on the schematic you put up for the amplifier that you did, there was a URL at the bottom of the schematic.
Oh, that URL. Let me. That URL is just there's a. It's using. It talks about tone controls and how to do it.
Right. Okay. So
that's all. That's all that was.
Yeah. So you're using sort of a design for the bass and treble.
That's right. If you want, I can show it to you.
Yeah, it caught my eye. I was kind of picking apart the bass and treble.
I do that now. I got to go here. I got to go share here, here, and now.
Yep. Mostly
this here.
It's like splitting the frequencies, high and low.
Yeah, that's right. There's a bass part and a treble part here, and this actually is a trim pot here, and a trim pot here. One day I'm going to learn how to do a trim pot design in LC Spice.
Yeah, I was going to say that doesn't look like a trim pot to my eyes, but what do I know?
Well, they're 100K on this side. It's 100K. They're 200K trim pots, basically, little ones. And, the idea, I started out with just the one preamp, this one on the left. And then I put the tone control in, and I was talking to Peter about it. And Peter thought, well, maybe to take care of some of the losses in the tone control, it'd be better to put this other preamp in. That's why the two. So we'll see how it works eventually. And there's a volume control here, and there's the LA380 power amp. So yeah, this was just for my own reference to know where I got the circuit from. And the circuit actually is it's a stereo circuit with 2 of these stereo, left and right, controlled by a balance pot, so to speak, on the input. Anyway.
Yeah,
that's what it is. Yeah.
Got it. Okay, thanks.
Okay, no problem.
All right. So I think that's it as far as the table, other than myself, which, again, I don't have a whole lot to report other than working on my laser cutting skills, and specifically 2D CAD, working with a program called QCAD to work with a cutting out of thin plywood sheets for my Morse code tutor. So learning a little bit about 2D CAD design. So still plodding away at that. I don't have a laser cutter myself, but the newly rechristened makerspace at the David Dunlap Observatory, which the formerly known as YLab. It was passed over to city administration for Richmond Hill. So now it's officially the DDO makerspace. So anyway, they have not one but two laser cutters now, and they've expanded to take over the entire basement of the main building beside the observatory there, and all kinds of metalworking going on, and they've got CNC and a row of 3D printers. Anyway, it's a good space there that they've got going on. So anyway, trying to utilize some of my membership and attachment to them to put some cases in my naked projects here. You know, I've got a bunch of things that are just boards sitting around, including Farhan's S-Bitex, which I just bought the board for several years ago, that I'd like to put inside a case too. So a little bit big for a 3D print, really, but a nice laser cutter will do a good job. So Cherry.
Where is that laser cutter space?
David Dunlap Observatory, Richmond Hill. So
okay.
Yeah, it's been there a long time, but the makerspace has been in existence about a decade, roughly. I think 2015 thereabouts they started. So anyway, yeah, it's a good group. It's actually thriving pretty well. Not a lot of electronics going on. They have had some things in the past where they've done workshops and presentations, that type of thing, on microcontrollers and what have you. But most of it seems to be focused around, like I said, 3D printing, laser cutting, metalwork. Those are the main things. But who knows? You know, now that in this transition to city administration, you know, the core group is still there and still running the day-to-day things, but that might attract you know, a different crowd. And you know, they used to run amateur radio courses there in conjunction with the York Region Club over in the past years. So anyway, it's a good group. So there you go. All right. Well, I think that is pretty much it for tonight's meeting. Next meeting is January the 21st. I believe, Michael, you may have something ready to go by that point on Common Mode Choke.
Yeah, I did a Common Mode Choke presentation before Christmas and gave it to the Mississauga Club. So I'm going to do the same for SOAREX.
Yeah, great. Okay, get it immortalized on YouTube, right? Yeah. There you go. Okay, very good. I'm not sure if Ken is back around for the hosting that meeting. I'll determine that and go from there. I saw a hand go up, but then I guess it got taken down. So, all right. Anyway, thank you very much for coming out, guys. Once again, Merry Orthodox Christmas, and we will see you all in a couple weeks. All right. So 7-3.
Good night, everyone.
7-3. Night.
Yep. Night.
Thanks.
7-3 all.